FreeCAD, with its BIM workbench, offers a free and versatile solution for designing homes and building. You'll be surprised at how quickly you can produce high-quality, professional-looking files, even if you're new to this software. This video is a tutorial specifically designed for beginners who are new to FreeCAD and want to learn how to use it for building information modeling and architecture projects. We will cover the essential tools and techniques that are commonly used in BIM workflows. The video is divided into chapters, allowing you to easily jump to the specific topic that interests you. By the end of this video, you will have acquired the necessary skills to create a detailed 3D model of this house using FreeCAD. You will also learn how to generate various 2D drawings, including floor plans, sections, and elevations, which are essential for construction documentation. And the best part of all of this? It's completely free. So, let's give this poor caveman a roof over his head. When you first open FreeCAD, a dialog box appears, asking you to choose a language, working units, and navigation system. I usually stick with the default options and select Blender as the navigation system. But since we're working on architecture, the standard is to use centimeters. So we need to change the units and set them to Building Euro. I'm also changing the navigation style for the Blender one. I'm selecting the light theme to make the icons easier to see for you. Since we're working on an architectural project, we'll spend most of our time in the BIM workbench. So, let's start by clicking on the Create an Architectural Project icon. It might take a few seconds for the workbench to open the first time as it's loading all the tools. A window will pop up, introducing you to the workbench's features and providing links to the documentation. You can click OK to proceed. In the following window, you'll find various display settings. Just change the first drop-down menu to centimeters. These settings aren't critical and can be modified at any time. FreeCAD jumps straight into the action, so zoom out a bit with your mouse wheel. Before we start, let's adjust the interface. Close the report view to maximize workspace and drag the taskbar to the right side of the screen. To improve accessibility of the tools, dock the sky blue snapping tools to the right-hand side of the interface. Drag the general modification tools to the left side of the second line. And finally, drag the annotation tools represented by a yellow letter A to the right of the second line. You should now have a better overview of all the tools. Now, let's move on to the fun part. To start a BIM project, we have several options. Personally, I like to begin by creating a building. A building is a container for all the 3D objects related to our construction. To create a building, simply click on the building icon. You'll see a new item called Building in the tree view. To keep our project organized, let's rename the building to something original and not common at all like house. You can rename the building with the F2 key. While our project only requires a single level, it's good practice to structure our project using levels, similar to how multi-story buildings are organized. We'll store all level-specific elements like walls and slabs within the level. It's a subcontainer of the building. With the F2 key, you can rename it Level 0, drag, and drop it into the house container. The most challenging aspect of this workbench is understanding how the tools work. Some tools require sketches, others need to be attached to existing objects, while others are standalone. Before we start, let's go over the different tools. The tools with yellow dots are for creating draft. Note that these draft geometry can't be constrained to each other and are harder to modify once created. I prefer using the Sketcher tool with red dots, especially if you're coming from the Part Design workbench. You can constrain and give dimensions with this tool. Next on our list, the 3D BIM tools. These tools are specifically designed for architectural elements, allowing you to create a wide range of building components such as walls, slabs, stairs, roofs, and doors. They also enable you to convert objects created in other workbenches by assigning the appropriate IFC class. Some tools require preliminary sketches. The blue tools allow you to perform various operations on both sketches and 3D elements. These operations include moving, copying, resizing, mirroring, and arraying. The Manage tools allow you to modify and add IFC properties to your objects. While it's important to structure your files correctly and assign the appropriate IFC classes to all your models for interoperability, we won't be focusing on that in this tutorial. The last tools are the annotation tools. These tools allow you to create dimensions, annotations, and section view directly into the workbench without using the TechDraw workbench. Let's start building our house by creating the main slab, just like in real life. We need to define its dimensions first. There are two ways to create our slab. The first is by using the yellow dot tools to draw a rectangle. If you're familiar with AutoCAD, this is a similar drawing process. Personally, coming from software like Fusion 360 or SolidWorks, I prefer using the Sketcher as I find it more intuitive. So you'll click on the icon with the white line and red dots. Notice that the view automatically orients itself perpendicular to the top view, making it easy to draw your slab as if on a piece of paper. Our goal is to recreate this sketch, which includes the house, front deck, and side deck. You can find the sketch image in the description for reference. To begin outlining our house, we'll utilize the rectangle tool. Click on the origin to establish and snap the first corner of the rectangle. Subsequently, input the dimensions 1250 for the width and 950 for the height of the rectangle. These dimensions will determine the overall size of our house footprint. To improve readability, you can move the dimensions to a more convenient location. We will proceed to define the deck's perimeter using the polyline tool. Start drawing a vertical line from the origin. If the line is perfectly vertical, you'll see a red vertical constraint appear along the line. Continue the line horizontally, extending past the end of the rectangle. Next, draw a vertical line upwards, ensuring it ends within the rectangle. Finally, draw a horizontal line from the end of the vertical line, connecting back to the rectangle. You can end the tool by right-clicking or pressing Escape. Using the Dimension tool, we'll input the deck dimensions. 300 centimeters for the width of the front deck. 200 centimeters for the width of the side deck, and 750 centimeters for the length of the side from the red axis. The sketch contains multiple closed loops, which is not ideal. We'll convert the internal lines to construction lines. However, there's an issue with the left line as it doesn't intersect with the deck line. To resolve this, we'll employ the Split tool to introduce a new vertex at the intersection point. Select both the newly created point and the intersection point. Then click on the Constrain Coincident icon to merge them. To prevent the two central lines from affecting subsequent operations, we will convert them into construction lines. Select them and activate the Construction Line tool. The sketch is finished and all constraints are applied. Click Close to exit. If you struggle to see the created sketch, you can hide the grid by clicking on the grid icon in the right side menu. To create the slab from this sketch, you need to click on the slab icon, which is represented by a yellow block in the top bar tools menu. This action fills the sketch and extrude it downward with a flat value of 20 centimeters. We can modify this value by selecting the slab in the tree view and going in the left side Data Properties panel. And under height, adjust the value to 60 centimeters to obtain a thicker slab. To keep the file organized, in the tree view, you can drag and drop the slab into the Level 0 container. By selecting the slab and pressing F2, you can rename the slab by Main Slab. We'll now draw the exterior walls using the Red Sketch tool. We can hide the slab by clicking on the eye icon next to it, as it would be easier to sketch the wall without it. Next, click on the Sketcher icon to start drawing. Our goal is to replicate this sketch, which depicts a rectangle with an interior offset. The dashed line represents the exterior wall boundaries, while the green line indicates the interior wall boundaries. Although the Walls tool automatically creates wall thickness, we will draw these boundaries explicitly. This will serve as a foundation for creating interior walls, which will originate from these interior boundaries. You will see in a minute. Let's use the Rectangle tool to draw the exterior walls. Starting from the origin and input a dimension of 1,250 centimeters for the width and a dimension of 950 centimeters for the height. We can adjust the dimensions for a more aesthetically pleasing result. To create the wall thickness, let's select all the edges and use the Offset tool. In the left-hand menu, check the Add Offset Constraint box and enter a value of -30 centimeters for the offset. The offset operation has created 4 construction lines which are not constrained. We will place them at the center of each respected edges. To do this, select the edge. Next, select one point of the construction line and apply a symmetrical constraint by clicking on the corresponding icon. The construction line will move to the center of the edge. You need to repeat this step for the 4 edges. We will use these construction lines to draw and constrain the sketch of the interior walls after that. Before closing the sketch, select the outer edges and convert them to construction lines using the appropriate tool. The sketch is fully green, indicating it's fully constrained. We can exit it by clicking on the close icon. To keep the file organized, we can rename the new sketch by SEXT wall using the F2 key. In order to create the exterior wall, we will use the Wall tool. To use it, first select the created sketch and click on the yellow icon with a brick wall. This tool will automatically create closed walls with a height of 300 centimeters and a thickness of 20 centimeters. To adjust these values, you need to select first the wall object in the tree view and go under the data properties in the left panel. Change the height for 350 centimeters and the width for 30 centimeters. When you make the main slab visible again, you can see that the exterior wall isn't perfectly aligned with the edge of the slab. When the wall is created, as default, it uses the sketch at the center of the wall. In our case, we have drawn the inside line of the wall, so the alignment should be set to left instead of center. We can see now the wall is perfectly aligned with the slab. With the F2 key, we can rename the new wall by EXT wall and drag and drop it into the level container. We'll hide the exterior wall and the slab and expand the exterior wall to see its sketch before creating the interior walls. Click on the sketcher icon to create the sketch for the interior walls. Our objective is to recreate this sketch, which is an open contour. The Wall tool accommodates this type of sketch. Note that the different lines within the sketch will represent the center lines of the respective walls. To start, we will create a carbon copy of the exterior wall sketch within this sketch. Click on the carbon copy icon and then select the SEXT wall sketch in the tree view. This tool will import the sketch while preserving its constraints, which we will then use as a basis for constructing the interior walls. We convert the green lines into construction lines by selecting them and clicking on the construction line tool. Let's use the line tool to create a horizontal line separating the living area from the bedrooms. Start and end your line on the inside construction lines of the previous wall. With the dimension tool, give a height of 500 from the inside right corner of the dotted rectangle. Employ the line tool to create the separation between the bedroom and the bathroom. Start your line on the top dotted edge and end it on the last created line. Repeat the same process for the line separating the second bedroom and the laundry. Draw a horizontal line between the 2 most recently created lines to represent the corridor between the 2 bedrooms. Draw a vertical line starting at the midpoint of the top dotted edge and extending downwards until it intersects the most recently created horizontal line. This line will represent the separation between the bathroom and the laundry room. To stop using the line tool, press Escape or right-click on your mouse. To ensure both central rooms are the same size, we need to make the 2 vertical lines symmetrical about the center line. Select the top point of the right line, then the center line, followed by the top point of the left line, and click on the Symmetrical Constraint tool. With the Dimension tool, we give a width of 110 centimeters for the corridor and a width of 160 centimeters for the bathroom. As the bathroom and the laundry are symmetrical, it would give a width of 160 centimeters to laundry 2. Using the line tool, we create the separation between the second bedroom and the second bathroom by creating a vertical and a horizontal line. The newly created horizontal line should be aligned at the same height as the existing horizontal line. To achieve this, select the endpoints of both horizontal lines and apply a horizontal constraint. Finally, with the Dimension tool, give a width for the second bathroom of 115 centimeters. While the sketch is fully constrained, we might not know the exact dimensions of certain elements. To determine the size, select the points and check the reference box in the Dimension tool. This creates a driven dimension that won't constrain the sketch. We can repeat this process to know the width of other rooms. We can now exit the sketch by clicking on the Close button. With the F2 key, we rename the new sketch by SINT wall. To create the interior wall, with the newly created sketch selected, click on the yellow brick wall icon. Similar to the exterior wall, this tool creates walls with a default height of 300 centimeters and a thickness of 20 centimeters. To adjust this, select the wall object in the tree view and go in the Data Properties tab in the left, scroll to find width, and change it to 10 centimeters. Also, change the height of the walls for 350 centimeters. Once again, use the F2 key to rename the wall for INT wall. And drag and drop it into the level 0 container. You can create a folder to store all the walls in the same place. To create a folder, click on the icon folder in the top bar. With the F2 key, you can rename it to Walls. Next, drag and drop the folder into the House Building container. Drag and drop the two Walls objects, and finally drag the Walls folder into the Level 0 container. You can make the main slab visible again and appreciate the work you did until now. To begin the process of adding windows and doors to our model, we will first need to select the specific wall element where we want to create these openings. In the project tree, locate and select the element labeled EXT wall. Once selected, click on the icon that represents the door creation tool. The menu below provides various parameters for creating different types of doors and allows you to modify general door properties like height and width, as well as more specific settings such as frame position and dimensions. If you try to place the door on the wall, you'll notice that it's difficult to snap. To make it easier, activate the Snap Endpoint option in the Snap menu on the right. Sometimes the door can snap to another object. To prevent this snapping, you can hide the main slab in the tree view. Right now, the door can only snap to endpoints. For more flexibility in door placement, enable the Snap Near option in the Snap Tool menu. This allows you to place the door more freely. To place the door precisely, you can enter a value in the local X field. However, I've found that this method doesn't always result in the desired door placement. In my experience, this placement method isn't very intuitive to use. My approach is to add reference points directly to the wall sketches. This allows me to precisely snap doors and windows to these points without worrying about their exact placement. So, we will delete the door we just create. The door object is stored into the EXT wall object. So select it and delete it by pressing the delete key. To create reference points, we'll need to go back into the SEXT wall sketch. Right-click it and choose Edit Sketch. Our objective is to add a series of points to the sketch. We will then add dimensions between these points, defining the sizes of the doors and windows, as well as the spacing between them. For reference, the image of the sketch is provided in the description. We will begin by focusing on the front face of the wall. As observed in this front view, there are 3 distinct windows. Therefore, we need to add 6 points along the edges. So select the Point tool and add 6 points on the bottom edge. Once the points are placed, utilize the dimensioning tools to establish dimensions as shown in the drawing. Remember that the wall thickness is 30 centimeters, so you'll need to subtract 30 centimeters from the overall dimensions at the beginning and end of each wall edge. To center the large window, select one endpoint, then the blue axis, followed by the other endpoint. Apply a symmetrical constraint using the corresponding icon. Using the dimensioning tools, determine the remaining missing dimensions. We'll repeat this process for the remaining 4 sides. The plans for each side will be provided as a reference. To speed things up, the video will be played at 3x speed. Feel free to adjust the playback speed at 0.35 if you want the video at the real speed. All these repetitive actions remind me of my terrible biology teacher in high school, who used to say that to remember something, you had to learn it and forget it 3 times. Here, with all these dimensions we're adding, I really think you will not have to repeat this 3 times to know how to do it. There's a French expression for that. C'est en forgeant qu'on devient forgeron, which could be literally translated as it's by forging that one becomes a blacksmith. That's the English equivalent of practice makes perfect. I'm curious to know if there are equivalents to this expression in other languages. Please let me know in the comments how you would say this in your language, or if there is another expression in English. I apologize for the interruption. Please continue with your hard work. Congratulations, you've finished adding all the reference points. You can now exit the sketch by clicking on the close icon. Now we'll place the doors and windows using the reference points we just created. To begin, we will make the SEXT wall sketch visible. So as to get a clearer view of the sketch, let's hide the slab. You'll notice that the sketch points are small. To make them more visible, select the sketch and go in the Properties View panel. Scroll down to find the point size and change the value to 8. In the 3D viewport, you should now see that the sketch points are much larger. I usually position windows and doors from the interior to create a recessed effect on the exterior wall. To add the first window, click on the yellow window icon. As you can see, you can directly snap the window to the points we created earlier. In the right side menu, give the window a width of 130 centimeters and a height of 210 centimeters. Be sure to input cm at the end of the value, otherwise it wouldn't work. Next, snap the window on the second point of the sketch and click to confirm. You can notice that the window didn't cut through the wall. I don't know if it's a bug or not. I noticed that I first select the wall before creating the window. I don't have this issue at all. I'm not sure if it's related or not. In the tree view, delete the sketch 003 and the window, which was affected to the INT wall. Delete the sketch 0042. Let's do things in the right order. First, select the EXT wall in the tree view, then click on the window icon. FreeCAD remembers the last values you entered, so you can directly place the window in its desired location. You can see that everything goes as planned and the EXT wall has been successfully cut too. Repeat the same process for next window. In the right panel, adjust the preset to sliding 4-pane and change the width to 400 centimeters. Next, snap the windows on the fourth point of the sketch. The third window will be identical to the first, so instead of recreating it like a caveman, we'll use the copy tool. This will allow us to duplicate and move the windows simultaneously. To do this, select the window object in the tree view and click on the copy icon in the toolbar. Click on the bottom left point of the window and snap the window on the sixth point of the sketch. You can zoom if you struggle like me. Now, let's add the upper windows. Select the window tool from the toolbar. In the right-hand menu, set the height to 100 centimeters. And snap the new window on the left top corner of the first window. For the windows above the large one, we'll place 4 identical 100 centimeters by 100 centimeters windows. So click on the window icon to create one. In the right menu, adjust the width to 100 centimeters. Snap the window into the left top corner of the big window, and left-click to place it. We will copy and move this window 3 times so as to obtain the same length as the big window. So select the window 004 and click on the copy icon. Next, select the bottom left corner of the windows and move the windows to the bottom row corner. You need to repeat this process 2 more times. FreeCAD offers an array of features which could be more efficient to create 4 exactly windows. However, if you use it, you will not be able to cut through the wall. So it seems you are stuck to repeat this process 3 times. For the last window of this facade, it's the same as the first one. So select the window 003 in the tree view and use the copy tool. Select the left bottom corner of the window and move it to the left top of the left window. Congratulations! You finished to place all the windows on the first facade. Take a time to admire your work and check if everything is okay. Before I let you fly the coop, let me show you how to place a window at a specific height from the ground. To place the window at the correct location, begin by snapping it to the reference point that you previously created within the sketch. Once the window is aligned with the reference point, you can then adjust its vertical position by modifying the z-axis value. You can adjust this value with the Move tool or directly in the Properties data panel on the left. Let me show you. Click on the window icon to create one. Change the preset of the window to Open to pane. Give a value of 120 centimeters for the width and 110 centimeters for the height. Next, snap the window into the second point of the sketch. Left-click to confirm the position. In the tree view, select the window 009 and click on the Move tool in the top toolbar menu. Left-click on the top corner of the window and press Z to constrain the move on the Z-axis. We want to align the height of the window with the height of the big right window, so click on the right corner of the big window. It will place the small window exactly to the same height as the big window. If you want to place the window to a specific place from the ground, you need to first select the bottom corner of the window. Next, press Z to constrain the move on the Z-axis, and then enter a value for the height. Or you can directly adjust the position in the Properties data panel in the Placement setting. You should now have everything to place the remaining doors and windows. If you're unsure about a window's size or placement, refer to the drawings in the description. I've sped up the video 3x, but you can slow it down to 0.35x if needed, and if you want to catch everything. If you find yourself getting weary of placing all these doors and windows, recall this proverb. C'est en forgeant qu'on devient forgeron. Perseverance is key. Congratulations! You have now finished placing all the windows and doors on the exterior walls. It was a lengthy process, but you completed it successfully. We will now move on to placing the doors and openings on the interior walls. This should be a bit easier. as we'll be working in a more free-form manner. We'll follow the same process for the interior wall as we did for the exterior. In the tree view, select the INT wall, and then click the door icon. In the right panel, choose Simple Door as the preset, and set the width to 80 centimeters. We'll place this door, which will be for the first bedroom, approximately in the middle of the corridor. Keep in mind, it might be a bit tricky to find the perfect angle to place the door in this spot, but with a little patience, you'll get it. Left-click to confirm the position of the door. We will repeat the same process for the 4 remaining doors. As you can see, the laundry room door has also cut into the living room wall. To adjust the cut depth, select the door in the tree view. Go to the Properties tab, and in the Data panel, set the hole depth to 10 centimeters. After adjusting this setting, the opening into the living room should be closed. You'll likely encounter the same issue with the 2 bathroom doors. You'll need to adjust the settings for that door as well, or you can use the Copy tool. To avoid this issue, we could create each wall independently. When performing Boolean operations, we would only affect the target wall, not all walls at once. Alternatively, we could set a default hole depth for all doors. For me, the most efficient way would be to adjust the settings for one door and then copy it to the other locations. This avoids recreating the door and modify the parameters each time. We're going to start creating openings in the wall. To do this, we'll use the same door creation tool as before. Change the preset to opening only and give a width of 115 centimeters. Place the opening at the bottom corner of the wall. It could be easier to hide the EXT wall to achieve this. The great thing about FreeCAD is that everything we've done so far is parametric, so if we make a mistake, we can easily fix it. You'll see why later. We're going to place the second opening for the corridor. Click the door icon and change the width for 320 centimeters. Next, place the opening between the 2 walls of the corridor. Left-click to accept the position. As you can see, the same issue has occurred with the bathroom wall. The Boolean cut has affected it as well. So go in the Data panel and change the value of the hole depth to 10 centimeters. As you can see, the opening is too large and extends beyond the door frame. To fix this, select Opening 001 in the tree view and go in the Data panel. Scroll down to find width and change the value for 310 centimeters. I don't think this is the best spot for the opening. Luckily, with FreeCAD, we can easily modify our design. Before making these changes, I'm going to show the slab and hide the SEXT wall sketch as we don't need anymore. To adjust the big opening, select the Opening 001 in the tree view. Then go in the Data Properties panel, scroll down to find the width value and adjust it to 290 centimeters. After that, scroll up to find the position setting and change the X value for 10 centimeters. I'm much happier with this size and placement. Now we're going to model the roof of our house. Depending on the roof's complexity, we can either use the dedicated tool in the BIM workbench or model it in the part workbench and then classify it using IFC. In our case, we need a simple single slope roof, so the dedicated tool in the BIM workbench should be sufficient. First, we will hide the interior wall and keep the slab and the exterior walls visible. We're now going to sketch the roof footprint. Let's start by clicking the sketcher icon. The objective will be to recreate this sketch, which is basically a rectangle. The roof will have an overhang of 150 centimeters above the deck and 100 centimeters for the 2 remaining sides. Select the Rectangle tool and draw a rectangle that covers the entire exterior wall and extends over the decks. With the Dimension tool, give a dimension of 1,500 centimeters for the top edge. Next, from the red axis to the top right corner, give a horizontal dimension of 1,050 centimeters. From the bottom right to the red axis, give a vertical dimension of 150 centimeters. And finally, from the origin to the right edge, give a horizontal dimension of 100 centimeters. The sketch is finished and fully green. You can exit it by clicking the close icon. As usual, let's rename the sketch using F2. We'll call it S-Roof. Now, we'll move the sketch to the desired height for the bottom of the roof. With the sketch selected, go in the Data Properties panel and change the Z value for 230 centimeters. You will see the sketch goes higher in the viewport. You can check your model in the left view to see if the sketch is at a good height. It looks okay for me. To create the roof, you need to first select the sketch and then click the roof yellow icon. As you can see, multiple slopes have been created following the outline of the sketch. To edit them, double-click the roof object in the tree view. A window will pop up on the right, allowing you to adjust various parameters such as roof shape, slope, and overhang. A description of all the parameters and their functions is also available. Feel free to experiment with the settings to see how they affect the result. In this case, we want a single slope roof. So we need to find the correct ID for our slope and set the run of the others to 0. The ID for our slope is the number 1. For the run value, we need to give a value of 12,000 millimeters and give 0 for the other ID. You can switch to a left side view for a better perspective. We need to set the overhang to 0 because we have already defined them in the sketch. We can also give a thickness of 300 millimeters. The angle of the slope is too steep. We can adjust it to 6.5 degrees to obtain a good result. That's look good to me. We can close the tool. Now, we'll cut the walls to match the roof slope. But before that, we drag and drop the roof into the house building container to keep the file organized. Next, select the roof and the EXT wall while maintaining control and click the less blue icon. As if by magic, the exterior walls are cut following the slope of the roof. Repeat the same operation for the interior walls. We're almost done modeling the house. We just need to add a slab for the back door and 3 sets of stairs. To create the back slab, we need to hide the roof by clicking on the eye icon in the tree view. Next, click the sketcher icon to start drawing the footprint of the slab. Use the rectangle tool to draw a rectangle above the top edge of the exterior wall. Use the dimension tool to set a horizontal dimension between the top right corner of the rectangle and the green axis. Give a value of 625 centimeters. Set a value of 100 centimeters for the right edge. For the top edge, set a value of 160 centimeters. And finally, give a dimension of 950 centimeters between the bottom right corner of the rectangle and the red axis. The sketch is fully constrained. You can close it. With the sketch selected, click on the slab icon. With the F2 key, rename the slab to back slab. Then drag and drop the back slab into the level 0 container. Change the value of the height of the slab into the Data Properties panel. Set the value to 60 centimeters. Then, to keep the file organized, create a slab folder. Move the folder into the level 0 container and finally drag and drop the 2 slab objects into the folder. We will now proceed with the modeling of the stairs. In the BIM workbench, you can create stairs with just one click. Locate the yellow stair icon in the toolbar menu and click it to generate stairs. By default, FreeCAD creates stairs with railings. In the tree view, you can expand the stairs object and delete the 2 railing and the associated wire as we don't need in our project. To modify the stair parameters, go to the Data Properties on the bottom left. We'll adjust the number of steps to 4 and change the height to 60 centimeters and the length to 60 centimeters. We want a solid staircase without any space underneath. So we need to adjust the structure thickness to 36 centimeters. There are countless parameters you can adjust to customize your stairs. For our project, the one we created is perfect. Now we're going to move the stairs to the back slab. To do this, we will use the Move tool. Select the stairs in the tree view and then click the Move tool. Select the bottom right point of the stairs and click to accept. Then move the camera to snap the point of the stair on the bottom left corner of the back slab. We're going to add another staircase to the side deck. Before creating it, let's measure the length of the edge by selecting it and going to the Tools menu, then Measure. We know now that we need to create a 200 centimeters wide staircase. You can exit the tool by clicking on Close. We're going to duplicate the object using the good old classic trusty Ctrl+C, Ctrl+V shortcut. This allows us to create an independent copy, which is essential since we'll be changing its width. In the Data Properties panel, find the width of the new stairs and change the value to 200 centimeters. Next, select the stairs 001 and use the Rotate tool. Select 2 point of the edge and apply a rotation of 270 degrees. Press Enter to accept the rotation. Next, select the stair 001 and click the Move tool. Select the bottom right corner of the stair and snap it to the bottom right of the deck. We will repeat the same process for the big stairs in the front. Select the long edge. Next, click the Tool menu and choose Measure. The measure is 1,450 centimeters, so we need to create a stairs with this value for the width. Select the stair 001 and Ctrl+C plus Ctrl+V to create a duplicate. In the Data Properties, adjust the value of the width to 1,450 centimeters. Next, use the Rotate tool to apply a 180 degrees rotation. And finally, use the Move tool by selecting the left bottom corner of the stair and snap it to the bottom point of the big slab. As usual, create a stairs folder to store the 3 stairs we just created. With the F2 key, rename it Stairs. Then, drag and drop the 3 stairs in the folder. And move the folder in the house building container. We've finished modeling the entire house. The great thing about FreeCAD is that we can automatically generate various plans, such as elevations, floor plans, and side views. Let's make the roof visible to see the entire 3D model. To maintain organization and facilitate future modifications, we will create a dedicated folder to store all of the 3D elements that comprise our house model. This folder will be named 3D Model. Drag and drop the house building in the 3D Model folder. Next, create a new folder and rename it 2D Drawings. We'll begin by creating a section plane to cut through the house and produce a section drawing. So click the icon of the section plane in the top toolbar. This will create a section plane at the origin. For our section view, we want to see the windows that are 100 centimeters above the ground. So, we need to adjust the section plane height to 110 centimeters. Next, we need to specify which objects we want to see in the section view. Double-click the section object in the tree view to open its properties. Next, go to the tree view and select all the objects you want to see in the section view. In our case, select all walls, windows, and doors. Once you've selected the objects, click on the Add Selected button. If you've accidentally selected any sketches, remove them as they will create unnecessary lines in the section view. You can click OK to close the panel. To generate the plan directly in the BIM workbench, select the section object and then click on the Shape Base View icon. A new object representing the section view drawing appears in the tree view. You can move it by right-clicking and translate. Move it to the left of the scene. We've successfully generated a section view of the house using this tool. As you can see, there's an error in our plan. especially the walls of the second bathroom. Let's investigate it. I think the issue is caused by the opening. It's too deep and not centered correctly. In the tree view, search the opening object and select it to access his data properties. Scroll down to adjust the value of the depth hole to 10 centimeters. It's better, but we can see the opening isn't not properly aligned with the wall. To correct this, scroll down in the data properties and change the value of the width from 115 centimeters to 110 centimeters. There's still a line showing in the plan, which means the hole isn't deep enough. So the opening isn't cutting the wall completely. Let's see the 3D model. The hole depth of 10 centimeters creates a zero thickness surface. To correct this, we need to change the value of the hole depth to a bigger one like 15 centimeters. It should resolve the issue. Let's see on the drawing. That looks perfect to me now. We can also display door opening lines directly in both the drawing and the 3D model. To do this, select all the doors you want to show the swing path for. Then scroll down in the data properties and set the value for symbol plan to true. This will automatically draw the opening lines for all doors, both in the 2D plan and the 3D view. To change the door's opening direction, simply right-click on it and select either invert opening direction or invert hinge position, depending on what you want to do. I'm going to adjust this setting so that all doors open the way I want them to. As you can see in the section view, the doors have been updated correctly. Once you've adjusted the door swing directions, move the section object and shape view to the 2D drawing folder. Now, we're going to create a layout of this section view. To do this, you have two options. Create the layout directly in the BIM workbench using the annotation tools, or use the TechDraw workbench, which is specifically designed for creating drawings. We will do the second option. So, go to the Workbenches menu and select the TechDraw workbench. The first step is to create a new drawing sheet. So click the icon Insert a Default Page. Using the F2 key, rename the sheet floor plan and move it in the 2D drawing folder. Next, go to the template properties and change the template to a blank A3 landscape sheet. As you can see, FreeCAD offers multiple style of templates. You can also use one of your creation. Your file should be in SVG to be open. To bring the section view into the layout, select the Shape 2D View object and click the Insert View icon. FreeCAD initially displays a front view of the object. To see the lines, we'll switch to a top view by clicking the downward blue arrow. Since the lines are at a 1:1 scale, we need to change the view scale to 1:45. Go to the properties and set the scale to custom, and then input 145. Now, the section view should be displayed correctly on the sheet. Click OK to confirm. Let's create a simple layout by adding some dimensions to get the sizes of rooms and exterior walls. To add a dimension, simply click on the Dimension tool in the toolbar. We will start by adding the dimensions of the exterior wall. Select the two endpoints. You can zoom if you struggle. You can see the elephant in the room. We need to resize the dimension because it's too big. You can go into View Properties and change the font size to 0.5 centimeters. However, this would only fix this specific dimension. Any new dimensions we create will also be oversized. To permanently change the size, go to Edit, Preferences, then TechDraw. In the Dimension tab, change the font size from 20 to 0.5. All new annotations will be created at a size of 0.5 centimeters, which is very convenient. We can now continue to add the rest of the dimensions to our drawing. I'm speeding this up because it's not very interesting. The TechDraw workbench provides tools to customize drawings. By selecting all exterior walls, we can apply a hatch pattern. After selecting all of them, click the icon Apply Geometric Hatch Face. In the Properties panel, you can choose the pattern you want, and you can add other parameters as you prefer. Once you're satisfied with the settings, click OK to close. Now we're going to create projected views of the 4 facades. We'll follow the same procedure as for the floor plan. We'll begin by adding a new page. Click the icon to do so. The next step, which can be a bit tricky, is selecting all the 3D models you want to see in the view. I'm going to expand all containers so I don't miss anything. Next, I select the lowest object, Slab 002 in this case, and then, while holding down Shift, I click on the topmost element, the house container. Next, I click on the Insert View button. Like we did with the floor plan, the scale is too large. I'll change it to Custom and set it to 1:65. Next, I'll move the view up to insert the opposite view below to create room for the opposite view. I repeat the same process to insert the opposite view. So select all the 3D objects and insert a view. I'll click twice the right arrow to find the view I need and set the scale to match the previous view. I'll position the view underneath the last one. Using the F2 key, you can rename it Front View and move the page in the 2D drawing folder. If you find the lines too thick, you can change their width. Select the view and in the View Properties panel, set the line width to 0.02 centimeters for both views. Now, we'll create projected views of the 2 remaining sides. Click the icon Insert Default Page and repeat the same process as before. Select all the 3D objects and click the icon Insert View. Click one time the right arrow and adjust the scale to Custom and give a value of 1:65. Click Apply and OK to create the view. Move the view at the top of the page and adjust the line width to 0.02 centimeters like the previous page. Repeat the same process for the opposite view. Select all 3D object and click the Insert View icon. In the right panel, click one time the left arrow and adjust the scale to Custom and set a value of 1:65. Press Enter to confirm. Next, move down the created view and adjust the line width to 0.02 centimeters. Our layout is now complete. You can add dimensions and annotations just like we did for the floor plan if you want. Before exporting the files, we will rename the last page side view and move it in the 2D drawing folder to keep the file organized. If you want to export your drawings, you can right-click somewhere in the page and choose Print All Pages. If you want to export the files as PDF, be sure to choose Microsoft Print to PDF for the printer. I advise you to change the orientation of the page to Landscape and click Print. Next, select a destination and a name for the file and click Save. Now open the file and check if everything is okay. In our case, we can see that some areas are gray out. To fix this, we'll go back to FreeCAD. Select the view in the Tree View. In the View Data Properties panel, search for the line face transparency and set the value to 100. You need to repeat this for the 4 remaining views. Once you have set 100 for the face transparency for all views, right-click on the page and print all pages again. Give the same settings as we did before and click the Print button. The file should be exported without the grayout issue. This brings us to the end of our tutorial on the fundamentals of BIM using FreeCAD. As you have seen, FreeCAD offers a powerful set of tools that can be used to create detailed and accurate 3D models for building information modeling. While it may take some time to master all of the features, with consistent practice, you can become proficient in using FreeCAD to produce professional quality work. If you'd like to support the channel, you can find a link in the description to purchase the 3D FreeCAD file for this house. I hope you learned something new from this video, or at least it was entertaining. Thanks for your attention.